In the previous P-Space lesson, the planning emphasis was on making the route itself safe and compliant before departure. That meant judging whether the route and area of operation was suitable, whether higher-level airspace requirements could be met, whether minimum flight altitudes protected the aircraft, and whether IFR planning minima kept destination and alternate options usable. This lesson builds directly on that pre-flight foundation. Once the flight is operating within controlled airspace, the focus shifts from planning suitability to live coordination with the air traffic services system. Operationally, this matters because a well-planned route can still become unstable if ATS is not used correctly, if SSR is not operated properly, or if changes to track or level are not handled with disciplined communication and control. By the end of this lesson, you should be able to explain the operator's responsibilities for ensuring correct use of air traffic services, describe the commander's responsibility to notify the appropriate ATS unit when operationally required, explain how SSR operation fits into safe controlled airspace use, and show why any departure from assigned track or cruising level must be treated as a controlled and communicated action rather than an isolated cockpit decision. As the lesson progresses from operator systems to commander actions, the aim is to build practical understanding of how ATS use, communication discipline, SSR management, and flight path compliance protect separation, situational awareness, and the orderly handling of traffic. Air traffic services are not an optional convenience layered on top of the flight. They form part of the operating environment within which commercial air transport is planned and conducted. In the lesson material, ATS use includes the appropriate application of air traffic control, flight information service, and alerting service wherever these are available and relevant to the nature of the flight. That means the aircraft is expected to be integrated into the service structure rather than merely passing through the airspace independently. Operationally, this protects the flight in several ways at once. It supports orderly traffic flow, preserves situational awareness, allows coordination between units, enables alerting and search and rescue support where required, and gives the crew a structured channel through which changes, deviations, and abnormal situations can be handled safely. The operator's responsibility regarding ATS begins long before the aircraft enters controlled airspace. It begins in the way the operation is designed, documented, and prepared. The operator must ensure that the use of ATS is built into the flight planning process, the operations manual, and the standard operating framework so that crews are not left to improvise their interaction with the ATS system once airborne. This includes ensuring that the operation is planned in a way that fits current route structures, anticipated levels, available services, and likely restrictions. The operator is therefore responsible not only for expecting crews to comply with ATS, but for giving them a planning, equipment, and procedures framework within which correct ATS use is both possible and normal. The first operator responsibility is straightforward in principle but important in practice. Flights must make use of the appropriate ATS units wherever those services are available and appropriate to the nature of the operation. This applies especially in controlled airspace, on designated airways, and within established flight information regions. The operational point is that commercial operations are not planned on the assumption that ATS can be bypassed whenever it feels convenient. Instead, ATS use is part of the expected conduct of the flight. That protects both compliance and safety. If the operator does not build that expectation clearly into the operation, the crew may be left with uncertainty about who must be contacted, what service is being used, or how the flight remains coordinated when conditions, routing, or workload begin to change. The operator must also ensure that an ATS flight plan is filed when required and that the operational flight planning process is coordinated with the ATS structure through which the flight will actually operate. This is not only an administrative requirement. A correctly filed plan supports coordination between ATS units, contributes to orderly traffic handling, and supports alerting and search and rescue functions if the flight later becomes uncertain or overdue. It also ensures that the planned route, intended flight levels, and applicable restrictions are visible within the system that will manage the flight. Operationally, a weak or poorly coordinated ATS planning picture can create avoidable friction later, because controllers and crews then begin from an incomplete or mismatched understanding of how the flight is expected to proceed. The lesson material places clear emphasis on maintaining communication with ATS and complying with instructions and clearances. For the operator, that means ensuring the aircraft is equipped and the crew are prepared to use the communication and transponder systems correctly. For the flight crew, it means the flight is conducted within an active communication relationship with the relevant ATS unit rather than drifting between intentions, assumptions, and partial coordination. This includes proper response to frequency changes, proper use of the assigned service, and disciplined compliance with route, altitude, and other clearances. Operationally, the point is simple: when communication becomes casual, the common operating picture between the cockpit and ATS begins to break down, and once that picture weakens, separation and traffic predictability weaken with it. The operator must also ensure that crews are prepared to support ATS reporting requirements and to manage ATS contingencies correctly. In practical terms, this means flight crews must be ready to provide position information where required, advise ATS about relevant deviations, and notify the appropriate unit when abnormal circumstances affect the planned conduct of the flight. The operator is expected to support this through procedures, training, and standardization, including preparations for communication failure or other ATS-related contingencies. This matters because ATS coordination is not tested only during routine flight. It is tested most heavily when the flight can no longer continue exactly as cleared, exactly as filed, or exactly as expected. A robust operator system therefore prepares the crew for both normal ATS use and degraded ATS situations. At this point, the lesson moves from operator responsibility to commander action. The operator creates the framework for ATS use, but the commander carries direct responsibility for applying that framework correctly once the flight is in progress. In controlled airspace, that responsibility is not passive. The commander must ensure that the aircraft remains coordinated with ATS, that relevant notifications are made to the appropriate unit, that SSR is operated correctly, and that any departure from the assigned track or cruising level is handled as an ATS matter rather than a private cockpit adjustment. Operationally, this is where planning discipline becomes real-time execution. A well-written procedure only protects the flight if the commander translates it into timely action, clear communication, and controlled decision-making when the air situation changes. One of the commander's central responsibilities in controlled airspace is to notify the appropriate ATS unit when the conduct of the flight requires it. The key ideas in that responsibility are timeliness, relevance, and correct addressee. The purpose is not to generate unnecessary transmissions, but to ensure that ATS is not left trying to interpret unexpected aircraft behavior without confirmation from the flight crew. In operational terms, notifying the appropriate unit protects separation, supports traffic planning, and prevents a change in aircraft status from becoming a wider system problem. The lesson therefore treats notification as a positive command responsibility. The commander is not simply reacting to questions from ATS. The commander is also responsible for ensuring that important operational information reaches the correct ATS unit when the situation calls for it. Notifying ATS matters because controllers work from a managed traffic picture. And that picture depends on accurate, current understanding of what each aircraft is doing and intends to do. If an aircraft's status changes and ATS is not informed, the controller may still be sequencing traffic, assigning levels, or assessing conflicts on the basis of information that is no longer true. That is why the commander's notification responsibility is operational rather than clerical. It protects the common understanding between the aircraft and the ATS unit responsible for the flight. It also reduces the risk that the aircraft will be interpreted incorrectly by units further along the route or by units coordinating adjacent sectors. Good notification therefore preserves predictability, and predictability is one of the foundations of safe controlled airspace operations. The quality of ATS notification matters just as much as the fact of making it. A late notification may leave ATS reacting after the situation has already affected traffic handling. A vague notification may force the controller to spend time clarifying what the crew actually mean. A notification to the wrong unit may delay action at the point where coordination is needed most. The commander's responsibility therefore includes judging which ATS unit is appropriate, ensuring the communication is made without unnecessary delay, and ensuring that the message gives ATS a usable understanding of the operational change or need. This is a disciplined communication task. It is not enough that the crew know what they are doing. ATS must also be able to understand it in time to manage the surrounding traffic environment safely. The lesson also focuses on the commander's responsibilities concerning operation of SSR. In controlled airspace, SSR is part of the surveillance and identification framework through which ATS interprets and manages the aircraft's progress. That means correct SSR operation is not a background technical detail. It directly supports the controller's ability to identify the aircraft, interpret its response correctly, and integrate it safely into the traffic picture. The operational message is therefore one of discipline. SSR must be treated as part of the flight's active coordination with ATS, not as a box that was set once and then forgotten. When the aircraft is operating in managed airspace, correct SSR use supports safe traffic handling in the same way that correct communication and clearance compliance do. The commander's responsibility regarding SSR is fundamentally about ensuring that the aircraft's transponder use remains consistent with the requirements of the ATS environment in which the flight is operating. The SSR response being generated by the aircraft must support ATS interpretation rather than confuse it. In practical terms, the commander must treat SSR as part of the aircraft's controlled airspace presentation to ATS. If the aircraft is meant to be identifiable and trackable within the surveillance system, the crew must ensure that the aircraft is not unintentionally undermining that picture through incorrect operation, neglected checks, or poor cross-monitoring. Operationally, the commander is responsible for making sure that what ATS sees and interprets from the SSR response remains aligned with the actual aircraft under control. A particularly important commander task arises when an ATS unit requests confirmation of the SSR code or seeks confirmation of how the SSR response is being interpreted. The operational point here is that such a request should not be treated as routine background chatter. It is often a cue that the controller is actively checking whether the aircraft's surveillance presentation matches the expected picture. The commander must therefore respond clearly and treat the request as a verification step within the traffic management process. If the aircraft and ATS are not aligned about the SSR presentation, that misalignment needs to be identified and corrected early. The safety value lies in restoring a shared understanding before the discrepancy affects identification, sequencing, or conflict assessment. The commander also has a direct responsibility concerning departure from the assigned track or cruising level. In controlled airspace, an assigned route or level is not a suggestion and not a private planning preference. It is part of the coordinated traffic solution under which the aircraft is being managed. That means any departure from the assignment must be treated as operationally significant. Even where the crew may have a valid reason to want a different track or level, the starting point is that the aircraft remains within the ATS clearance structure unless and until that structure is amended or unless safety requires otherwise. Operationally, this prevents uncontrolled variation in aircraft behavior from eroding the predictability on which controlled airspace separation depends. The commander's responsibility becomes particularly important when the aircraft cannot remain on the assigned track or cruising level. In that situation, early recognition and timely coordination with ATS are essential. The operator's framework already requires crews to remain in communication and to support deviation reporting where needed, and this is where the framework becomes operationally critical. A departure from the cleared path or level is not only a flight path change. It is a change in the assumptions under which ATS is protecting the surrounding traffic. The commander must therefore ensure that ATS is not left to discover the change through late observation or inference. The disciplined response is to bring ATS into the developing situation as early as practicable so that the system can manage the consequences safely. It is useful to understand why the lesson places such strong emphasis on compliance with assigned track and level. In controlled airspace, ATS is not managing one aircraft in isolation. It is managing a system of intersecting routes, levels, sector boundaries, and future traffic interactions. One aircraft drifting from its expected path or level can therefore create effects well beyond its own cockpit. It may alter separation assessments, force replanning for following or crossing traffic, and complicate coordination between adjacent units. This is why commander discipline matters even when the aircraft itself appears stable. Operationally, staying where ATS expects the aircraft to be is part of how the flight protects not only its own safety, but also the safety and orderliness of the wider traffic environment. When an ATS unit asks the crew to confirm the SSR code and the ATS interpretation of the response, the commander's responsibility includes more than simply repeating a number. The response should help ensure that the aircraft and ATS are aligned on how the aircraft is being seen and understood within the surveillance environment. If there is any mismatch, ambiguity, or uncertainty, the commander must treat that as an operational issue requiring resolution rather than as a minor technical distraction. This is important because surveillance misunderstanding can affect identification, coordination, and controller confidence in the aircraft's presentation. Clear confirmation and prompt attention to any discrepancy help preserve the reliability of the controlled airspace picture on which later instructions and separation decisions may depend. The lesson material also supports a broader operational point. ATS discipline becomes even more important when the flight is no longer entirely routine. Communication difficulties, unexpected operational changes, deviation from the planned path, or any situation in which the aircraft's behavior may no longer match the filed or cleared picture all increase the value of prompt ATS coordination. The operator is expected to have contingency procedures reflected in the operations manual and SOPs, and the commander is expected to apply those procedures in a way that keeps ATS informed as the situation develops. The safety logic is consistent throughout this lesson. The more abnormal the situation becomes, the less acceptable it is for ATS to be left uncertain about what the aircraft is doing or intends to do. Returning to the operator perspective, Good ATS use does not happen reliably by expectation alone. It has to be normalized through procedures, SOPs, training, and standardized operational practice. The operator is responsible for ensuring that crews understand how ATS use fits into the conduct of commercial air transport, how communication and reporting responsibilities are carried out, how ATS contingencies are handled, and how the transponder and related systems support surveillance and traffic management. This matters because inconsistency between crews creates inconsistency for ATS. If one crew treats notification, code confirmation, or clearance discipline casually while another treats them correctly, the wider safety system becomes less predictable. The operator's responsibility is therefore not only compliance, but standardization of compliant behavior. Viewed as one operational sequence. The lesson forms a clear chain. The operator plans the flight so that ATS will be used appropriately, the required flight plan is filed, route structures and likely restrictions are integrated, and contingency procedures are available. The crew then enters controlled airspace with communication discipline, correct use of the assigned ATS service, and proper SSR operation. If ATS requests confirmation of code or interpretation, the commander responds in a way that restores or preserves common understanding. If the flight cannot remain on the assigned track or cruising level, the commander treats that immediately as an ATS matter requiring coordination. The lesson therefore describes controlled airspace discipline as a sequence of connected responsibilities rather than a series of isolated cockpit tasks. Several recurring errors sit behind poor ATS use in controlled airspace. One is assuming that once the aircraft is in contact with a controller, the ATS relationship will look after itself without active crew discipline. Another is treating SSR as background equipment rather than as part of the aircraft's live surveillance presentation to ATS. A third is allowing the aircraft to move away from the assigned track or cruising level without appreciating how quickly that affects the wider traffic picture. A fourth is delaying notification because the crew are trying to solve the problem entirely within the cockpit first. The lesson's preventive logic is clear: do not let ATS discover important changes indirectly, do not allow surveillance understanding to become uncertain, and do not treat assigned path or level as flexible unless it has been properly coordinated. A practical self-checking habit supports everything covered in this lesson. Before and during controlled airspace flight, the commander and crew should be able to answer a few simple operational questions. Which ATS unit is currently responsible for the aircraft? Is communication active and correctly managed? Is the SSR presentation being operated in the way ATS expects? Are we remaining on the assigned track and at the assigned level? If not, has the appropriate ATS unit been informed promptly and clearly? These are not advanced technical questions, but they are powerful ones. They keep the crew aligned with the basic disciplines that preserve the traffic picture and reduce the chance that a small cockpit issue becomes a wider coordination problem in controlled airspace. To close, This lesson is about active coordination in controlled airspace. The operator must ensure that ATS is properly built into planning, communication, reporting, flight plan filing, and contingency procedures. The commander must then ensure that the aircraft remains properly coordinated with the appropriate ATS unit, that SSR is operated in a way that supports correct surveillance interpretation, and that any departure from assigned track or cruising level is treated as a controlled and communicated event. The learning intent is operationally clear. In controlled airspace, safe flight depends not only on flying the aeroplane accurately, but also on preserving a continuous, reliable, and shared understanding between the cockpit and ATS. That is what keeps traffic orderly, predictable, and safely separated.